triangle similarity, angle angle, side side side, and side angle side. Our objective is to prove certain triangles are similar by using angle angle, side side side, and side angle side, as well as use triangle similarity to solve problems. Who uses this? Engineers use similar triangles when designing buildings, such as the Pyramid Building in San Diego, California. Let's look at a postulate. The angle-angle similarity postulate states if two angles of one triangle are congruent to two angles of another triangle, then the triangles are in fact similar. Let's look at an example. Explain why the triangles are similar and write a similarity statement. Well, since PT is parallel to SR, we can use the alternate interior angles theorem. So using the alternate interior angles theorem, we can state that angle P is congruent to angle R and angle T is congruent to angle S. Well, since two angles are congruent, we can state that triangle PQT is in fact similar to triangle RQS by angle similarity. Let's look at a couple of theorems. The side-side-side similarity theorem states if the three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. And the other theorem we have is the side-angle-side similarity theorem. If two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the triangles are similar. Let's verify that the triangles are similar. So we have triangle PQR and triangle PRS. Well, if we look at our sides, we have PQ and PR, and if we do that, we have 4/6, which gives us 2/3. And then we can do QR over RS, which is 4/6, which also gives us 2/3. And we can do PR over PS, which would be 6/9, which is 2/3 as well. Therefore, we have three similar sides, so the triangles are in fact similar by side-side-side similarity. Let's look at this next one. We have triangle JKL and triangle JMN. Well, we can see that J is a common angle in both of these triangles. Therefore, it has to be congruent by the reflexive property of congruence. Now let's look at a couple sets of sides. Keep in mind that one triangle is 2 with 3, and the other one is not 4, but 6 and 9, because it's the entire triangle, not the trapezoid on the bottom. So, JK over JM, which would be 2/6, is 1/3. And then we have JL and JN, which would be 3/9, which is also 1/3. Therefore, by side-angle-side similarity, our triangle JKL is similar to triangle JMN. Finding lengths in similar triangles. Let's explain why triangle ABC is similar to triangle DBE and then find BE. The reason for this is you can't simply just set up a proportion with any old figure. You have to make sure that your figures are similar before you do so. So with a triangle, we can utilize some other pieces of information. Now, There are a couple ways you can go about stating that these triangles are similar. You can use that angle ABC is congruent to EBD to give you one of the angles by vertical angles theorem, or you can notice that AC and ED are parallel, which means that by the alternate interior angles theorem, angle A and D will be congruent, and angles C and E will be congruent. Either way, you've got at least two angles that are congruent. Therefore, the triangles are similar by angle-angle similarity. Now that the triangles are congruent, or similar, sorry, now you can find BE and set up a proportion. So AB over DB equals BC over BE. If we plug in our known values, we'll have 36 over 54 equals 54 over BE. And now we can cross multiply. 54 times 54 and then 36 times BE will give us 54 squared, and we have 36 times BE, and we can simplify that to 2,916. And if we divide both sides by 36, BE ends up being 81. Let's look at a couple of proofs. Given A is the midpoint of BC and D is the midpoint of BE, prove that triangle BDA is similar to triangle BEC. Well, we can start with the fact that our given information is first. So we have A is the midpoint of BC and D is the midpoint of BE. Using the definition of midpoint, we can then state that BA is congruent to AC and BD is congruent to DE. Well, if we utilize the hint that we have here, because we know what the next statement is, we're going from congruent to equals. The reason being is you need to use an equation, so you can't use an equation with congruent. You need an equal sign for an equation. So we can use the definition of congruent segments to change our congruent statement into an equals statement. Now we can utilize the segment addition postulate. So BC is equal to BA plus AC, as well as BE equals BD plus DE. So our large piece equals our two smaller pieces added together. Our large piece BE equals our smaller pieces BD and DE added together. Now, we can utilize the substitution property and substitute some pieces of information. We know that BA equals AC, so if we substitute BA in for AC, and then the same thing here, BD in for DE, we have the equation as follows. BC equals BA plus BA, and BE equals BD plus BD. It's just starting to limit some of the amounts of unknowns that we have. Alright, so let's simplify this. We have BC equals 2 BAs and B equals 2 BDs. And now we can utilize the division property of equality to make BC divided by BA kind of almost represent a proportion. So BC over BA equals 2 and BE over BD equals 2. Therefore, if we substitute or utilize the transitive property, we have BC over BA equals BE over BD. Now, the reflexive property has angle B is congruent to angle B. Therefore, our triangles are in fact similar. We have our two sides, and then we have a set of angles. So, therefore, by side angle side similarity, our two triangles are in fact similar. Let's look at one more. M is the midpoint of JK N is the midpoint of KL, and P is the midpoint of JL. Prove that triangle JKL is similar to triangle NPM. My hint is use the triangle midsegment theorem and side-side-side similarity to do this. So in our proof, we will start with the givens. So we have M is the midpoint of JK, and we have N is the midpoint of KL, and P is the midpoint of JL. So then we can utilize the triangle midsegment theorem because we have MP equals half of KL. We have MN would equal 1/2 of JL, and NP would equal 1/2 of KJ. And then similar to the last one we did, we can simply use the division property and divide by KL, JL, and KJ, and we will end up with MP over MP over KL equals MN over JL, which equals NP over KJ, and all of those equal 1/2. And we use the division property of equality. Well, if all three of our sides are in fact proportional, then we know that triangle JKL is similar to triangle NPM by side-side-side similarity. Let's look at a couple properties of similarity. We have the reflexive property of similarity, which is triangle ABC would be similar to triangle ABC. We have the symmetric property of similarity, which would be if triangle ABC is similar to triangle DEF, then triangle DEF would be similar to triangle ABC. And the transitive property of similarity would be if triangle ABC is similar to triangle DEF and triangle DEF is similar to triangle XYZ, then triangle ABC would be similar to triangle XYZ. These are all very similar to ones that you have learned in the past for equality and congruence. And that ends our lesson on triangle similarity, angle-angle, side-side-side, and side-angle-side.